Hello and welcome to my second lesson on integration. In this lesson I want to take you through definite and indefinite integrals. Since in the first lesson I took you through the definition, and you can always check the video that was posted before this one. And so let's begin. Definite and indefinite integrals. Now consider the following integrals. We have the integration of 2x plus 4 with respect to x. We have the integration of the same thing, but we have an a and a b indicated on below and above the integration sign. What we have here is definite integral. What we had at the beginning is indefinite integral. This is indefinite and this is definite. Indefinite is what we have done or dealt with so far. And let me say this, we are going to concentrate on definite integrals in a short while, but let me say some few things that we did in the definition about indefinite integral. And this is what I want to say. In indefinite integrals, we simply do integration as integration is done at the definition. For in the same case, we also have an included c, which is simply what we do to integrate. For example, if we're integrating 7x with respect to x, we get 7x plus c. If we're integrating 2x plus 4, the function we have up there, the answer will be simply x squared plus 4x plus c. If we are integrating 8x cubed plus 3x squared plus 4x plus 3, with respect to x, we get the function that you get there. So we are simply integrating. Remember every time to add a c. In the application of integration, we normally don't deal a lot with indefinite integrals. We deal with the definite integrals because the application part of it is does not have this kind of operation, and that's what I want us now to major on. We shall be using the application of integration on finding area under the curve, and I must mention that the indefinite integral is just probably mentioned for definition purpose, but for application and what integration is used for, we normally use the definite one. And so let's concentrate on the definite integral. Now we have the function 2x plus 4 integrating with respect to x, and we have a number written here 1, and we have another one here. This is how we read this. We say integrating the function 2x plus 4 from the limit a to 4 with respect to x. So if I read this properly, it will be integration of 2x plus 4 from 1 to 4 with respect to x. Integration of 2x plus 4 from 1 to 4 with respect to x. Remember that whenever you're given this kind of a thing, the number below here is always smaller than the one that's up there. So we are integrating the function from a to b, where a is smaller than b, or what you have in the brackets there. So please, that's just an important aspect. All questions about definite integrals will have limits. The limits are like an a and a b, where the a is smaller number than b, and that's that. But now how do we do the integration? To integrate this, we normally just do integration. Remember, this function 2x plus 4 is this one here, and so we have x squared plus 4x, x squared plus 4x. The c here, we don't have a c here. The limits 4 and 1 also appear at this end part of the rectangular brackets, and it's done exactly like that. And here they do it that particular way. There's no c. Okay, and I think the limits are included. Mark those two. But we continue. To continue now, we have the two brackets kind of put twice. The brackets now put twice. We have the x squared plus 4x, which is this one here, only that we have replaced the value of x with 4. That is, instead of having x squared, we have 4x squared. Instead of having 4x, we have 4 times 4. Let me say that again. This is repeated down here twice, where the 4 is first of all replaced in the x squared, so that we have 4 squared instead of x squared. For 4x, we have 4 times 4 minus the same thing, but now this time replacing the value of x with 1. So you have 1 squared plus 4 times 1. So what we have here is this bracket replacing the value of x being 4 minus the same thing replacing the value of x with 1. So this is the first one, this is the second one, and that's how we use the limits. Okay, since we're integrating the value, the function 2x plus 4, and the integration is this, you replace the values of x first of all with 4 minus the same thing when x is 1, and we just progress, which will be, this will be 32 minus 5, and the answer is 27. What about if we included the c? Or why don't we include the c? Let me answer that by following the following process. We have a 4 squared plus 4 times 4 plus c. It is just this particular function. I've just added a c with the one in red there. Then this other one here, the same one here, but plus c, the one that's happening in red there. And therefore this will be 32 plus c minus a brackets 5 plus c, which is 32 minus 5 plus c minus c. What does that tell you? C is subtracting itself away, and therefore we don't have the c at all. So we don't need to have the c. And that happens to be a major part I need to mention there. We should not add the c when you're doing definite integral. So what's the difference between definite and definite? Definite integral, we don't have c. In indefinite integral, we have the c. Definite integral, we have limits, which is normally operated like I've explained here. In the indefinite integrals, we don't do. We just simply integrate and add the c. Let's go to actual examples on definite integrals. We have a question there. We are told integrate x cubed plus 6x squared plus minus 4x plus 1 with respect to x from 2 to 4. And therefore, the integration of this, following the rules of integration, is going to be this one here. Remember, we are not adding the c. Now, I have simplified this by cancelling out the second term and the second and third term by 2 and 3 respectively. So we have that. Now we use the limits. We're going to replace the value of x with 4 minus the same thing replacing the value of x with 2, and therefore this is a function here. So we have x raised to power 4 plus 2x cubed minus 2x squared plus x. When you replace with 4, we're going to have x raised to power 4 over 4 plus 2 with 4 cubed minus 2 with 4 squared plus 4. The value of x is 4. Then the same thing, but the value of x being 2. So we have now 2 raised to power 4 over 4 plus 2 into 2 cubed minus 2 into 2 squared plus 2. And continue, simplify. You get the answer is 164 minus 14, which is 150. I hope that's okay. Ensure that you follow what I've done there. It's just integration, replacing the value of the limits from with 4, then subtract the same thing when the values of the limits are 2, and that's that. Another question is integrating 4t cubed minus t squared plus 2t minus 1 with respect to t. This time around we have a function that's expressed in terms of t, so the y should be integration of this with respect to t, which is going to be this function here. And again, we need to simplify this part here so that we have it that particular way. Okay, even this one should be simplified, that one there. We have the limits 5 and 0, so we're going to put 5 where we have t, simplify, subtract, putting 0 where we have t, and that's what we have on this other side. We have everything, the 5 raised to power 4 minus 5 squared all over 3 plus 5 squared minus 5, then the same thing with 0. And I should mention that everything here will reduce to 0, so I don't even to think a lot about that. And that means when we are having limits where one of the limits is 0, it easily reduces to 0, that particular bracket, and therefore we just have to deal with one bracket and just continue appropriately. And therefore the answer is 1810 all over 3 minus 0, sorry, which is going to be 603 and third. Remember, you leave your answer as a mixed number, like that particular one there. Another question we have is this one here, and we're integrating from -2 to 0. I say the limits are such that the one that's below here is smaller than the one that's up there, and you see the case here. We're integrating u squared plus 2u with respect to u, and therefore we integrate like this particular way. I've simplified this one here to be this one. Put the limits. When you first of all put 0, everything here will be 0, like this one. But the one that was -2, you just put everything to be -2, and it appears to be what we have here. Okay, and so what is the answer? This one becomes 0, so I don't need to think about it. I'll just need to have this negative and simplification of this particular part, which is -8 over 4 minus 4. Please don't be cheated that this is a positive 4. It's negative. The negative is, we have 3 negatives here. There is one for -2 times -2, then there's one outside, so it's -4. Simplify to become -20 over 3, which is 6 and 2 over 3, because this negative and this one cancels out. And I think that brings us to the end of my second lesson on integration. Check out for the next one, which is about application on area, and I hope you find it helpful. Please like, comment, subscribe. I appreciate those people who have been thanking me for the videos. Thank you.